Okay, so today we're in section 9.5, irrational numbers. Irrational numbers. So a couple things you need to know about irrational numbers. It cannot be written as a fraction. Okay, A over B. That's the complete opposite of rational. We said that rational numbers could be put into a fraction form if they were indeed rational. Well, here irrational numbers cannot, and they are non-terminating and non-repeating. We need to explain specifically what that means for them to be non-terminating and non-repeating. Okay? Then this is a repeat of what we said in 9.4, but we need to say it again. Real numbers are all rational and irrational numbers. There is no such thing as, what's the opposite of real? Fake number. There's no such thing. Okay? So it's literally all the numbers in the universe fall into one of these two categories. Okay? So we need to make sure that we understand that. It's either one or the other. There's no in between. There's no other kinds of numbers. It's just either rational or irrational. Okay, so we're going to work 6 numbers. 6 numbers. And this is very much a blend of what you learned in section 9.4. You need to write down all 6 of these numbers. Give yourself some space. I actually probably don't have enough space on my slide, so it's going to get kind of squished together. But write all 6 of these numbers down. And we have to determine, there's going to be a section just like this on your quiz on Wednesday. We have to determine, are these numbers rational or irrational? And simply saying one or the other is not enough. I have to have a why. I have to have an explanation. Okay? And my explanation is going to be in me saying, this number is a repeating decimal. This number is a terminating decimal or an integer or non-terminating, non-repeating. Okay, so those are going to be some of my reasons. All right, go ahead and write down each of these 6 numbers. You can write them vertically or horizontally, but you do need some space in between so we can actually label and categorize them. All right, so the first number, 0.121221,222. All right, so what's significant here, what we need to pay attention to, is this ... at the end of the number, okay? The ... at the end of the number means that the digits keep going, all right? So we see that, too, when we put numbers in our calculator, the screen is only so long, right? Okay, so we'll see that ... keep going, all right? That means that the numbers continue on, so this for sure is non-terminating, okay? But that doesn't mean that it's not rational, because for it to be rational, it can either be terminating or repeating. So I need to determine, is this a repeating decimal? All right, well, start with the first digit, 1. Are all the digits 1 after it? So the 1 is not repeating by itself, but what about 12? And then here's 12 again, but is my third set a 12? Is it 1, 2, 1, 2, 1, 2 all the way through? No, so that doesn't work. What about 1, 2, 1? Is it 1, 2, 1 next? No. So even though these numbers are pretty close, it's 1, 2, 1, 2, 2, 1, there is no pattern. So this is irrational. And it is, every time it's irrational, you're going to say the same thing. Non-terminating, non-repeating, and you can abbreviate. Okay? Non-terminating and non-repeating. Every time it's irrational. What makes an irrational number? It does not end. It does not stop. It's not 1.3 or 2.52. Okay? It's non-terminating and non-repeating. So now let's look at the next one. The negative square root of 196. Well, as it's written right now, I cannot determine. I must be looking at the decimal version of the number, not a fraction, but a decimal. So if you see a fraction, or if you see a square root, or even a cubed root, you have to evaluate that. All right? Well, this is actually one of my perfect squares. You actually should know this one. Anybody? Now I'm taking volunteers. Anybody? Anybody know? Leah? Square root of 196? You're close. She said 13. Caleb? It is 14. So negative 14. What do you think, guys? Now that you see, okay, this is the number, do you think that's rational or irrational? What's the criteria? Is that terminating? Does that decimal stop? There even is no decimal. It's 0.0. Yes, absolutely. Okay? So, rational numbers, is that confusing to you guys? Are y'all struggling with that? What terminating means? Okay, what does it mean to terminate something? It stops, right? Do you see that number keep on going and going and going in your calculator? No. Okay, so it stops. So this is absolutely rational. You could say because it's an integer, right? Integers are negative and positive numbers that don't have a decimal value. Or you could even say that it's a terminating decimal. Integer, rational. If all you say is rational, that's not correct. You're not going to get any points for that. Okay? So you have to say why. What is the why? It's naming it. What is it? Okay? Here, it's an integer. All right? It's real simple when it comes down to what makes it rational or irrational. If you see a number that keeps on going with no pattern, it's irrational. Everything else would be rational. You just have to categorize it. Let's do the next one. The cubed root of 2. When I put the cubed root of 2 in, I get 1.25992, and it keeps on going to the end of my calculator screen. So I know that this is not a terminating decimal. The digits keep on going and going and going. Is there a pattern? Guys, we just talked about it. Is there a pattern here? No. Irrational. Non-terminating. Non-repeating. All right, I want you to answer the next one. The negative 0.25 repeating. Is this a rational or an irrational number, and why? If you say irrational, that means that it does not terminate or repeat. If you say rational, it means it's got to be a whole number, an integer, repeating decimal, or a terminating decimal. You tell me. Raise your hand when you have your answer. What is it? What does that bar tell me? That it's a repeating decimal. All right? So, guys, it's right in front of you. Anytime you see a repeating decimal, you're going to say it's rational because it's repeating. Even though it keeps on going and going and going into infinity, there is a pattern here. Okay? All right. What about pi? Pi. When you convert pi to a decimal value, what happened? 3.14 and on and on and on with no pattern and no end in sight. So I say it's irrational. Pi is irrational. When I convert pi, everybody see your pi button on your calculator? Okay? When I convert pi to a decimal, it keeps going with no pattern. What about the cubed root of 15? What about the cubed root of 15? What is the cubed root of 15? You see that? All right, these should be really, really obvious to you, especially when it's irrational. It just keeps going with no pattern and no ending point. Okay? So both of these are irrational, non-terminating, non-repeating. Okay, I just kind of ran out of room, so since they were both irrational, I just kind of combined the reason. All right? So for every one of these homework problems tonight, if all you write is rational or irrational, you will not get credit for the problem. You hear me, Sam? Okay? You don't get credit for the problem. You have to tell me why. If it's irrational, it is the same reason every time. If it's rational, it can be an integer, meaning a negative number that does not have a decimal. Negative 7, negative 10, negative 15, negative 20. Could be a whole number. Basically a positive number that has no decimal. 5, 10, 15, 20, 12, whatever. It could be a terminating decimal. Someone give me an example of a terminating decimal. Caleb. 1.23. It stopped. Okay? What's another example of a terminating decimal? Come on, guys. This is super simple. Jakari, 3.14, if that was it. Okay, pi is not terminating, though. There. All right, what about a repeating decimal? Someone give me an example. This is so easy, guys. Come on. Come on, wake up. What's a repeating decimal? Robbie, give me one. Repeating. 0.12 repeating. 1, 2, 1, 2, 1, 2, over and over. All right, so those are some of my reasons that it could be rational. Here's example 2. Okay? You do not have to write the entire like basically phrase. Okay? Approximate square root of 71, negative 24, square root of 8. And we're doing it to two values, the nearest integer and the nearest tenth. All right, so let's go ahead and set this up. You need probably 2 to 3 lines in between. We're going to the nearest integer and to the nearest tenth. All right, approximate the square root of 71, negative 24, and the square root of 8. Here's what's going to be true about every problem that you solve in this category. None of them will have an even square root. We actually learned about our perfect squares. We learned about our perfect squares, right? Okay, perfect squares, let's say them. What's my very first perfect square? 1. 1 is my first perfect square because 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. What's my next one? 16. 20, same with me, 25, 36, 6 times 6 is 36, 49, 64, same with me, 81, 100, 121, 144, 169, 196, and 225. You have to know your perfect squares, all right? So what I saw last hour was I saw students writing what they thought to be a perfect square, and it wasn't. Is 6 a perfect square? No. Is 12 a perfect square? No. Okay? So if you don't know those perfect squares, you're not going to get the section correct. So those perfect squares are really important because here's what I'm going to do. The square root of 71 is closest to what perfect squares? On the low side and on the high side of 71. So 71, what is the closest perfect square that is less than 71? 64. So I'm going to write the square root of 64 is less than the square root of 71. True story? Yes. Okay. Now, what's the nearest perfect square that is greater than 71? What is it? 81. 81, that's okay. That's okay. All right, so now here's the work that you have to show me for every one of these. Your calculator will not show you this. So remember, we're going back now to your calculator could do all the work for you on these problems. How do I know that you understand why the answer is what it is? You're showing me this step right here on every problem. So without this step, there is no credit. So here's what I have to decide. Is 71 closer in value to 64 or to 81? How many units is it away from 64? How many units is it away? 7 units from 64. And how many units from 81? 10, right? 71 to 81, that's a difference of 10. So just based on that, it's only 7 units from 64. It is closest to 64. And what is the square root of 64? 8. So I would say if I'm approximating this to the nearest integer, meaning a number that has no decimal, it's closer to 64, and the square root of 64 is 8. So that's what it's going to be. Okay? And you need to circle which one it's closest to. All right, so I think I do that in just a sec. Hold on one sec. I don't know why I did that. So you're going to circle the square root of 64 because that's the one it was closest to. All right, now get out your calculators. take the square root of 71. The square root of 71. Okay? Now, that confirms it's 8 point what? What's the square root of 71? 8.4, and you're going to write the first two decimals. 8.42. Okay? So, this confirms what I just did. The 4 keeps the 8 the same, right? So, if I was rounding to the nearest integer, right here, my decimal value, the 0.4, confirms that I would round it down to 8. But now I'm going to round it to the nearest tenth also. So what does the 2 do to the 4? Does it raise it? No, it keeps it the same. Approximately 8.4. Okay? And these are my two answers. I rounded to the nearest whole number and to the nearest 10. Square root of 71 would round to 8 and 8.4. But your work there, guys, is you doing some work here. It's not just your calculator spitting the answer back at you. You understand why. Why is it approximately 8? Because it's closer to that perfect square. All right, so now let's do this next one. The negative square root of 24. Don't worry about the negative, okay, and determining what is the nearest perfect square that's less than 24. Don't worry about the negative. What's less than 24 and what's the nearest perfect square greater than 24. I want you to try to set up. Okay. Negative square root of 24. Which one is less than 24 and which perfect square is greater than 24? Fill it in right now. I'm going less than 24. What's the next perfect square that's less than 24? What was it? 16. 16. All right, now put in that negative, but that didn't have any factor or effect on which one it is. Okay, now guys, this one's really close, right? What's the next perfect square that's greater than 24? 25. So clearly, which one is it closest to? 25. It's only one away. It's literally only 1 unit away. So what do you think is going to be true about your decimal value if it's literally that close to a perfect square? It's going to be a pretty high decimal value, don't you think? Okay, if it's that close, what is the square root of 25? 5. So don't forget your negative. So you now take the square root of 25, which is negative 5. So that is the one that it is closest to. We approximated it now to the nearest integer. All right, now put the negative square root of 24 in your calculators. 4.89. I told you that was going to be a high decimal. And doesn't that make sense? Don't you think it's going to be pretty close to 5? Right? So the 9 rounds the 8 to a what? To a 9. Approximately negative 4.9. And it makes sense because it's only 1 unit away from a perfect square. My decimal value is going to be really, really close to 5. Okay? So we can use a little bit of logic there. All right, I want you to do the last one completely on your own. Approximate the square root of 8 to the nearest integer and tenth. The nearest perfect square below 8. 4. What's the nearest perfect square greater than 8? 9. Which one is it closest to? So circle it. What's the square root of 9? 3. Now you're done with the integer. Okay? See, a lot of people here put 16, and while 16 is a perfect square, it's not the next one. You see that? You just forgot about 9. Very common mistake that I'm going to see here. Okay? So just watch out for that. You've got to pick the next one. All right, so now it's 2.82, right? Which rounds the 8 to 8. Okay, 3 and 2.8. Who got that right? Everybody get that right? Okay, we're doing okay. All right, so that's approximating. The last thing I'm going to do is something that you actually did on your last test already, except now, instead of it being rational numbers, these are going to be irrational numbers when I take the square root. So all you need to do is write the first few decimal values until you can see a difference. What is, okay, so what I want you to do on your notes is write down each one of these. I'm comparing 3 sets of numbers. And then I want you to evaluate. You cannot say, oh, well, this one's bigger without showing any work. You need to show me the decimal values, and then you can say which one is bigger. Okay? So go ahead and write these down, and then I want you to take the square root of 35 and write it below, and the cube root of 80. No rounding is necessary. All right? What is the square root of 35? Just give me the first couple. 5.91, okay? Or what is the cubed root of 80? Okay, 4.30, okay? I am not worried about you showing work on how you found square and cube root, but I need to see these decimal values. Now, which one is clearly bigger? 5.91. So in your final answer, you must go back and write it in the original format. All right, so that's something I probably didn't make clear enough in the last unit, but I will now. Okay, when I see your answer, you don't write the decimal as your answer. That's your work. This is your work. Without this, you're not going to get credit on a homework assignment or a quiz question. But that's not your answer. Your answer is back in the original format. Square root of 35 is bigger, and I can see that in your decimal values. All right, so now I want you to do the next one, okay? Write the number, the first couple of decimal digits, and then in the original format, box in the answer that is greater. The explanation, guys, that I'm looking for, that's your work. That's your work. Let's do the second one first. I know that some of y'all are already doing the third one. What's the square root of 8, guys? Tell me. Come on. 2.82. We actually just did that. What is the square root of pi? 3.14, the decimal value. Okay, so I can clearly see which one is bigger. Pi. All right, who got that right? Who said pi? All right, now this next one. What is the negative square root of 2? Don't say the answer yet. And the negative cubed root of 10. Find the decimal values, but then remember what it's asking. Which value is greater? All right, write your answers down. All right, what's the negative square root of 2? Okay, what's the cubed root of 10? Okay, this is not where you write your answer. Which one is greater? Not in the decimal. Negative square root of 2. Here's why. Negative 1.41 is closer to 0. Remember, in the negative, the farther it gets from 0, the lesser the value on a number line. All right, so let me draw this real quick for you on a number line just to show you. So here's my number line. Here's 0 up here. Here's negative 1, negative 2, and negative 3. So negative 1.41 is somewhere here. Would you guys agree? It's about halfway between negative 1 and negative 2. Negative 2.15 is down here. Negative 2.15 compared to negative 1.41. This one is greater. It's closer to 0. Do you see that? You don't have to draw the number line, but you need to understand the farther in the negative you get away from 0, the lesser the value. Okay? Did you guys get that? Yes. All right, so that's everything for today's lesson on section 9.5. You've got homework tonight, and we'll check that tomorrow.